All right. So there's countless ways to do a WLAN denial of service attack in Kali. You can use the Aircrack suite of tools. You can use, I believe Kismet has a way to do denial of service attacks. There's all different types of tools that allow you to do it. And one of my new kind of favorite tools to use for denial of service attacks, or just kind of a way to script it and make it easy, is a BetterCap caplet. Now, we've talked about BetterCap before, and it's framework for sniffing and spoofing and all that kind of stuff. And it's got a pretty good amount of caplets that are already there. I thought I would show you, which is under, depending on how you do the install, it's under user share BetterCap and caplets. So if we look at what these caplets are, you can see there's some here for, start at AP or Facebook phishing, GPS, and there's Bluetooth stuff. I mean, there's all different types of fun caplets. And what a caplet is, just as a reminder, is it's a pre-built set of variables and flags for the tool to use. Okay. So if we're looking to do something and we don't want to have to remember the exact syntax every single time we run a command, you can create a caplet, kind of like you did in Wi-Fi Pumpkin. Okay. So there's several different caplets that are already here, but one of these I wanted to look at was the mass deauth with you. So if we do that, let's go ahead and just do cat and mass deauth. And basically what this is going to do is we've got the interface that's already there. I already have our interface in monitor mode. So we went over how to do that earlier, but it's using a ticker option. So this is going to repeat the deauth attack pretty regularly, and it's going to jump to each channel unless we uncomment our recon channel or tell BetterCap to just focus in on a channel. Now, all the WLANs that we've been attacking currently are on channel 40. So instead of just modifying this, you could use Nano and modify this, uncomment that, and put in your channel. But instead of doing that, what we're going to do is we're going to start this for, we're going to start up the tool, and then we're going to use a command in BetterCap to change the channel there. So it might get a couple other people for a second, but you'll see it's going to work for what we need it for. So, all right. And if you're ever wondering the arguments to put in with tools like this, just throw in the help flag, and you can see right there it's looking, caplet string. So you got to call out the interface too. So BetterCap, and we need to iFace WLAN 0. And remember, my adapter's already in monitor mode from the previous attacks we did. So it's in WLAN, it's already in monitor mode. And then we're going to use the caplet command. And these are already known to BetterCap. So all we have to do is just grab the caplet we want to use, paste that in there, and then this is going to start right away. Now, what we're going to do is I'm going to start up my screen capturing over here on the phone. And then we are going to focus our attack. So we're going to do a Wi-Fi.recon.channel 40. And then Wi-Fi.show. So these are the ones we're actually going after on channel 40. And if you look at my iPhone, which I'm going to paste up for you right here, you're going to notice that every 10 seconds, man, we are getting knocked off. Okay. And it happens over and over and over. So this is a pretty cool way to deauth a lot of people and keep it going. Okay. Now, again, disclaimer, anything that you've seen in this class, we're not condoning it 100%. This is for your testing, your labs only. You want to be specific whenever you do your test, because if you're deauthing other people's APs and you're not confident in what you're doing, then that's actually there could be criminal laws you're breaking. So don't just do this carelessly. Always specify a channel you want to focus on. Make sure it's your AP there, and all that kind of good stuff. But anyway, this is a cool tool to do a WLAN DAuth attack, and they basically just put in a little script to kind of redo it every 10 seconds. So yeah. So one more thing I wanted to show you guys was I realized we didn't really show a capture of the DAuths happening. I've showed you the iPhone on the screen, but I thought it would also be fun to do an example of what's going on with the capture. So I went ahead and ran the attack again, and I did a capture this time, which placed the capture file in the directory which I ran the attack from, which was the capsules directory, or the caplets directory. Now, if we take a look at this file, we can just do Wireshark R, and then we're going to throw this in there to open up that particular capture. Now, you start off by seeing beacon probe request, okay, then check out the DAuth frames, right? One after the other, and then bam, DAuth again. And we've got that channel frequency on here, so you can see at first we're not being too stealthy, okay, about the attack. Now, I'm in a pretty secluded area, so, and I've got curtains up and soundproofing in my room here. I am seeing a few other things, but I'm doubting it's affecting them too much. Let's go ahead and do, now this is a filter, okay, where we're looking for DAuth frames. So these are the DAuth frames that are happening. And as you can see, man, they just start going crazy. And you can see the ones where we start getting focused on channel 40 because it's just my Apple device over and over and over going, what the heck is going on? What the heck's going on? So if we remove that filter though, and we come down here, you can see that we start probing again. So there's a DAuth, we get an acknowledgement from the client. Okay, so we get an acknowledgement, DAuth, get an acknowledgement, and then we start with our probe request on all these guys again down here to get connected again. So now, remember, this would not work if we had PMF enabled on the WLAN. So if protected management frames are enabled on the WLAN, then this attack would not work. This is only valid for attacks that are not using PMF. Now, you might be thinking, well, what about WPA3? WPA3 PMF's a requirement of, and OWE even has, they've got a transition mode. Now, in the transition mode, PMF is not 100% required. It is really required by RFC if you're going to do OWE by the standards. But you may find some that are not using PMF, and that's part of the reconnaissance again. You got to figure out what everybody's using to figure out the appropriate attack for that environment. So I hope this was enjoyable, and we will see you guys in the next one.